So today we are going to do this example of finding the present value in arithmetic progression, also known as an arithmetic gradient. So Dolly takes out a loan and agrees to make payments every month for 1 year, at which time the debt will be paid off. The initial payment she will make is $500 and it'll be increased by $10 each month. The annual interest rate is 12%. How much is the loan? Okay, so first things first, we need to use this equation to find the present value. The present value is essentially how much the loan is. So we need to fill in everything else. So A is the annuity value. So how much is she paying each month? Well, technically it's different amounts because the first month it's 500, then it's 510, then it's 520, and so on. However, the gradient will account for that. The gradient will account for the increase later. So we really just want to know how much the initial payment is in this situation. So I would put A is equal to 500. Okay, next thing is the interest rate. So the interest rate is 12%. However, she's making payments monthly, right? So we need to switch that to monthly. So we are going to divide by 12 to get 0.01, right? So 12% a year is equivalent to 1% every month. Next, we have n, which n is going to give us the number of compounding periods that there are. And it says that she's going to pay this every month for 1 year, right? So every month for a year, that means there's 12 payments she's going to make and 12 compounding periods. So therefore, n is equal to 12 for that reason. All right, and then the last one is G, the gradient. So the gradient is how much we go up or down every month in comparison to the initial value. So each month, the loan is increased by the dollar amount of $10, right? So month 2, she pays 510, month 3, she pays 520, then 530, and so on, right? That's how it works. So what we're going to do is put gradient is $10, since that is how much extra she pays each month compared to the previous month. Okay, now we're going to plug all of this into this massively long equation. So the first part of the equation talks about the annuity value for the initial $500. So that's why it looks quite familiar to us, probably from the annuities unit. So PV is equal to 500 times 1 minus 1 plus I, so that's going to be 1.01 to the power of negative n, so negative 12, all over I, so over 0.01, and then plus the gradient over I, so gradient is 10 over I, which is 0.01, and then times 1 minus 1.01 to the power negative 12 over I, so over 0.01 again, and then minus n, which is 12, times 1.01 to the power of negative n, so negative 12. Cool. Okay. So my suggestion here is let's add these up separately. So first, we're going to figure out what this entire thing is, this first part here. Okay, so let's go ahead and do that. So first I'm going to do 1.01 to the power of negative 12, hit equals. Then 1 minus that number, hit equals again, divided by 0.01, hit equals, times 500, hit equals, and the number you should hopefully get is 5,627 and 54 cents. Okay, then I'm going to add the next part here. So first I'm going to figure out what's in these brackets, and then I'm going to multiply it by 10 and divide by 0.01 at the very end. Okay, so let's do 1.01 to the power of negative 12 equals 1 minus that number equals, divide by 0.01 equals, and then minus, actually, you know what? Just to be safe here, let's figure out both those numbers individually and then solve it overall. So here we're going to have 10 over 0.01 times 11.255 approximately, for this part, and then minus, let's see what this is, 1.01 to the power of negative 12 equals times 12 equals 10.649 approximately, like that. And then let's figure out what that is. So 11.255 minus 10.649, because better safe than sorry. Always better to do something simpler with the calculator than something more complex that could end up getting you the wrong answer or having the calculator misinterpret what it is you mean. So I'm going to subtract these numbers, and then I'm going to multiply the result by 10, and then divide that result by 0.01, and get 606. So the present value is $5,627.54 plus $606. And then let's add those together, and we get that the present value overall is $6,233.54. So there we go. So therefore, the loan that she took out originally was $6,233.54. If you have any questions, please feel free to leave those in the comment section, and we'll see you for the next one.